All right, we're moving out of the foundations into our first major area of troubleshooting, and of course, it's going to be the Cisco Call Manager. Cisco Call Manager, now called Unified Communication Manager, is the core of the entire Cisco Voice over IP network. And as we focus in on Call Manager, there's a massive amount of troubleshooting areas to explore. The first one that I want to hit is the most common one that you're going to run into every single day on the job working in a unified communication network, and that's the endpoints. My phone won't register. My phone has an error message. Every time my phone boots, I get this warning message about such and such. All of these things get into the endpoint registration process. So what I want to do as we walk through this nugget is look at the IP phone boot process, review that with you, because that's the core of everything endpoint troubleshooting. Then we'll look at troubleshooting from the IP phone itself. If you're sitting at a device, what can you do from there? If you're sitting on the call manager, what can you do from there? And then a specific focus on SIP devices and what kind of areas of troubleshooting they might have. The IP phone boot process is probably about 90% of your troubleshooting of endpoint devices. Because if the phone boots and gets to the call manager, it's going to work. If it's showing an extension there, I mean, unless you have some kind of physical problem like the handset no longer works or something to that effect, that's a completely another category of issue. But most of the problems that you'll have is the phone is not booting correctly. It boots cycles, it stops at a certain point and kind of locks up. All of those kind of things focus around the boot process. So, when you get a Cisco IP phone and you plug it into a switch, first thing that's going to happen is the switch is going to detect inline power or power over Ethernet capability. It uses one of two methods. You've got the Cisco proprietary, I guess you could call it now, inline. Cisco refers to that as inline power. And then you have the industry standard 802.3AF power over Ethernet. Now, using one of those two methods, depending on what the phone supports, so right there is troubleshooting. If your phone's not powering up, you may check your switch and say, is this one that only supports the Cisco proprietary inline power, the pre-standard, or is it one that only supports 802.3AF, and my phone only supports the legacy standard? So it's kind of this weird mix that we have, and I, being the budget shopper that I am, set up a client, and I went online for a power over Ethernet Cisco switch, and I found a Cisco Catalyst 3524 inline power switch for like $200, like a 24-port switch. And I thought, this is perfect. It was a small company, perfect. And so I grabbed that switch, and sure enough, I got it, and it only supported the Cisco proprietary inline power, and all the phones that they had and wireless access points used the 802.3AF power over Ethernet. So be careful when you're looking at those devices. Same thing goes for phones. A lot of the phones support Cisco proprietary inline power only, the older phones. And the thing with phones is, I mean, sure, they change and they upgrade. New stuff's coming out all the time. But people don't change out phones like they do computers. I mean, phones can stay for decades on a network without being upgraded. So you might run into a lot of old phones supporting that power standard. So either way, switch detects it, bzzz, get the power down the line. The phone goes into what I call Christmas tree modes, where all the different lights start blinking, red, green, yellow. All the different lights kind of light up as it power cycles, and that's the phone booting its software image. So it's going through, and whatever software it has installed, it'll have some kind of software installed, is booting up and initializing, saying, you are a phone, you need to get an IP address. Now the phone will receive from the switch its voice VLAN information if you have voice VLANs configured. Now that's if you have Cisco phones, because they are received using CDP. Here's the bizarre thing. As you may know, a phone can be on a separate VLAN from the PC that's attached to it. So you have your phone, you can daisy chain your computer and only run one Ethernet cable to each cubicle in your organization. Now, with that capability, you have to put the phone and the PC on different VLANs. That's a security factor. So we can say the phone is VLAN 100 and the PC is VLAN 200. The way that is possible is the phone tags its packets. So it's kind of like a small trunk connection is created between the switch and the phone, and the phone handles that trunk and sends tagged packets into the switch. Well, the computer has no idea about VLANs. It sends untagged packets. So whatever packets come in tagged from the phone are put on the correct VLAN. Whatever packets come in untagged from the computer are put on whatever is assigned to the access VLAN on the switch. So the phone can receive that information via CDP. Now that's the good news about buying Cisco phones. If you buy non-Cisco phones, like Avaya or some other vendor, they don't support, of course, Cisco Discovery Protocol. So that means you'll have to hard code and manually type in on those phones the voice VLAN information, or a lot of those phones have other methods that they can receive the voice VLAN, like a certain DHCP option or something like that, that you won't have to configure each phone individually. Either way, we would never buy anything other than Cisco phones, so Cisco phones receive it via CDP from the switch. Now the phone, once it gets its voice VLAN information, sends a DHCP request. It's going to send out a broadcast method on whatever VLAN it's on saying, hey, I need an IP address. That request goes out and is forwarded to the DHCP server. Now I have all these servers separated into 3 different server boxes here, but they could very well all be one box. This is just for ease of example. I mean, the DHCP server could be in this switch, could be a layer 3 switch, could be in a router, whatever. So the DHCP server gets the request and sends back to the phone typical characteristic items like IP address, subnet mask, the default gateway that phone has. You might also assign DNS information, but one critical piece of information that should always be in your DHCP scope is DHCP option 150, which is the IP address of the TFTP server. The phone is going to get all its IP configuration from the DHCP server, but it needs to know where to go next. It needs to know I have an IP address, and here's the IP address of the TFTP server, because on the TFTP server is held its configuration file. Now that could be a specific configuration file for this phone if it's previously been configured, and if you look on the TFTP server, it'll be a file named SEP and then the MAC address of the phone .cfg or something to that effect. The extensions can change based on what kind of configuration file it is, but it'll always be SEP and the MAC address of the phone that is receiving. And that will be the phone's specific configuration file. Or if this is a brand new phone that's never registered, there will be some generic configuration file. It won't be called generic, but it'll be some like default XML config file that is sent over to the phone, just telling it what call manager to use. So regardless, the phone gets its IP address and option 150 from the DHCP server, and now says, okay, TFTP server, please give me my configuration file. TFTP server looks to see if it has a file that is TFTP or SEP something something something. It'll be requested by the phone. It's looking for that file. If not, then the phone will say, well, then just send me the generic one, and the TFTP server sends that back. Regardless of what file it gets, there's always going to be one piece of information that is in that file that the phone needs, and that is the primary call manager it should use when it registers. Now a phone can use up to 3 call manager, primary, secondary, and tertiary, and they'll all be listed in that configuration file. So once it gets the config file from the TFTP server, it's now going to contact the first call manager in that list. It's primary. If that one's down, it's going to go to the secondary, and if that one's down, it's going to go to the tertiary call manager and try and use one of those. Now, that's the final point of registration, because that is where the phone gets its extension assigned. That's where it's going to get dial tone. All the skinny messages are sent that we've been talking about in the foundations nuggets just before this one. All the skinny signaling is going to come over to that phone and say, here's your phone, here's your soft keys, or here's your phone number, here's your soft keys, here's your button configuration, here's the dial tone, here's the music on hold. All of that stuff comes from the call manager. And the only way the phone knows which call manager to go through is by that configuration file. So, let's talk about troubleshooting from this. The phones speak loudly. When you're watching them boot, and when you get into a call manager environment, that's constantly something you'll be doing. You plug in the phone, the screen kind of lights up, Christmas tree mode. It will come up and it will tell you each and every step that it's doing. It will say, contacting, voice VLAN information, receiving IP address, attempting, or it says something like configuring IP, and that tells you it's in step 4. It'll say contacting TFTP server. It tells you it's in step 5. Now, if any one of those steps are unreachable, like it can't get an IP address, or the TFTP server's unable to be reached, maybe it's on a different subnet, we don't have a default gateway, whatever the case may be, that's where the phone will stop, and you'll see it hang at that message, and then it reboots. And it goes through the same thing all over again. Configuring IP, contacting TFTP, going through all of that list, and then reboots. And whatever the last step that it's rebooting at, whatever the last step is that it's at, that's where you can start your research. That's where you can start formulating your plan and going, okay, this phone doesn't seem to be able to reach whatever device it's telling me. Alright, so let's look at some of the common possibilities for phone registration failure. Number 1 is the network connection. Always check the network connection. Make sure that you're plugged in, and make sure that you're going to a switch port that has the right voice VLAN configuration for you. Let me bring up connection to my switch right here. I'm going to do a show CDP neighbors, and I've got some phones, looks like, attached to fast Ethernet 0/6. So let me do this. I'll do a show CDP entry. Let me right click that, paste that in, and do star, so it shows me all that. It shows me it's a 7970 connected to fast Ethernet 0/6. I see all the power requirements. It's currently drawing 10 watts of power. That's all interesting information, but what I want to see is the port configuration. Do a show run interface fast Ethernet 0/6, and you can see that right here I have switchport access VLAN 200. That's the data VLAN. Switchport voice VLAN 600. So that is what configures the port to be in the correct VLAN for the phone. So I need to make sure that VLAN 600 has, I'll do a show IP interface brief. VLAN 600 has a routable IP address. You can see it's 172.30.60.1 is the IP address assigned, so that's going to be the default gateway for the phone. I would want to make sure that DHCP is set up for VLAN 600. So one of the first things to always make sure of, when you're looking at network connection, make sure that you're in the right VLAN and that VLAN has a DHCP scope configured for it. From there, we can look at the IP configuration problem. Is this a manual or DHCP based? Well, this switch happens to be my DHCP server for the voice over IP network. So I'm going to do a show run begin with DHCP. And right here is my scope for VLAN 600. I can see the network is 172.30.60.0. Default router is the switch, 172.30.60.1. DNS server right here is some DNS servers that I use. Here's an internal one, and if that's down, it's going to use a public DNS server. This is my domain name for my house, which is where I'm at right now. And option 150, there it is. That's the DHCP option that allows it to go to the TFTP server, and that happens to be the IP address of the TFTP server, which is also my call manager. Those two functions are combined into one device here. Notice that all these other VLANs and scopes, you can see I've got a Cisco Lab, one for VLAN 200, VLAN 100. All these other scopes do not have an option 150. So if my phone were to end up in the wrong VLAN, it's not going to get the TFTP server IP address, and it's going to end up failing. So always check your IP configuration issues, also manually on the phone itself. Now, the phones I have sitting in front of me are sitting in front of me, meaning you can't see them. So they actually have menus on screen that are able to be configured. They look exactly like this. Of course, this is the IP communicator, and I'm not going to get the same menus in this settings area as I would on the phone, but this is where I would go on the phone. I would go to the settings menu on the phone, and they would actually have a field here called network configuration. On a physical phone in front of you, it's option number 2. The reason they don't have it on the IP communicator is that you set your network configuration from the preferences tab. So this is where I say go use this TFTP server, and this IP phone or soft phone goes out and uses that. So there's no need for it here. But if I manually have the phone configured, then that's where I would want to go to resolve an IP configuration problem. The TFTP service failure. You'll want to check your call manager itself. If call manager is the TFTP server, which 90% of the time it is, I have not configured a voice over IP network yet where call manager is not the TFTP server for the voice network. But you'll want to go into the Tools menu and go to your service activation. First of all, I guess that'd be the logical starting point to say, is my TFTP service even activated? This is what allows the call manager to be the TFTP server. I then go to the Tools menu, check my control center. Let's see, is it under Feature Services or Networks? Probably under Network. Oh, no. It's not. It's right there. It's Cisco TFTP. Make sure that guy is started. It's active. It's running. If it's stopped, your phone is not going to get there. You can also, from the phone itself, and I'll show you some things you can do from the phone later, but from this settings menu right here, hit the status and check your status messages, and you'll actually see what configuration file the phone is requesting. And you can see at 9:28 a.m. this morning, which is when I powered this guy up, it requested SEP, blah, that's its MAC address, .cnf.xml. So, and this is primarily for Call Manager 4, that's one where you would go to the Call Manager itself, in the TFTP server directory, and I say this is Call Manager 4 because in Call Manager 6 the TFTP directory is not as accessible, and check and see if that file is there. And if it's not finding that file, it will actually say in the status message, file not found, looking for default file. You can also, and by the way, in the status messages, this is a huge place to go to find out issues happening with the phone. It shows a lot of the messages from the boot process that happen. You can see CTL update fail, and that's okay. The CTL is the Certificate Trust List, which is what updates what servers are allowed. It's used for security for the phone. And I see it's failing, and that's no big deal because I haven't updated it, and I'm not using a Certificate Trust List right now because my network is running without IP phone security at this point. So TFTP service failure, that's what that is. Call Manager service is not running. That's the same place. We're in the serviceability area under the control center. You want to check your Cisco Call Manager service. Make sure that guy is running. If it's stopped, this call manager is dead. It's not servicing phones. So that would be an obvious place for failure. Bad firmware or configuration file. This happens sometimes if you change the firmware, which can happen if you go to the administration system menu, and we have the well, it used to be called Device Defaults. Oh, actually, sorry. Call Manager 4, it's under the System menu. Call Manager 6, it is under the Device Settings menu. So they moved it over here. This in Call Manager 4, it's under System, and this is where you specify all the load informations, the firmware files that the phones will use. Now, it's pretty rare that you'll go in and say, okay, I want to update just for, we'll say, the 7961. I'm going to change this firmware file on the Call Manager itself to a custom one. Usually it's just when you upgrade Call Manager to the new versions, the new patch releases, 6.0 becomes 6.1, all these firmwares will be automatically updated by the Call Manager upgrade, and it will put those new firmwares on the TFTP server. So you want to make sure that when you come in here, this firmware file hasn't been changed, or somebody hasn't gone in, just gone, oh, I deleted it, or whatever the case may be, because the phone's not going to be able to find its firmware. So make sure that the firmware file is specified. Make sure it hasn't been deleted from the TFTP server as well. Bad configuration file. This just happens sometimes. And sometimes there's just no rhyme or reason behind it. Here's the idea. You configure a phone on the network. It's working, and then it just stops. It boots, it's showing, it's getting its config, and it's just, it comes up and says registration rejected, and you're like, what is the deal? There's just weird things that happen. And I'm not going to say it happens all the time, but it's, in my opinion, it's happened here and there, and I would usually call them, and forgive me for saying this, a bug. It's usually a bug with Call Manager. Like a phone's configuration file just gets whacked out. And the best thing to do, if you just have, if your phone is just not registering, you've tried, you checked DHCP, you verified it's getting an IP address, it's on the right VLAN, all of that stuff, and it just makes no sense. What I usually do is just delete the phone in Call Manager, meaning, jump up. See, where are we? Right here. Go to the device menu, go to phone, find your phone that's not registering, find it in your list and say, okay, it's this guy right here. Check it, delete it. and then create a new phone with that same configuration. You can even copy and paste the MAC address out of it and so on. Just reconfigure the phone. And what happens when you do that is it reconfigures the configuration file on the TFTP server. It generates a brand new configuration file. And I found more often than not, if it's just something that makes no sense, like all the phones are working except this guy, the port's configured right, the scope's configured right, he's just not registering, try deleting it and recreating it in the call manager. That regenerates the config file. Endpoint incorrectly or not configured. That's enough said. You go into the call manager right here. It's got a bad MAC address. It's incorrectly configured, or you don't have a phone configured for it. It's not going to register correctly. Or your security settings. You might have phones have to manually type in a key to initially receive their certificate and their security. You might be typing the wrong key code, or the security just might be configured incorrectly for the cluster. Let's now visit the specific troubleshooting steps you can take from the phone or from the call manager themselves to resolve some of these issues. First and foremost, these phones are computers, little mini computers, and sometimes they just freeze. It's not very often. The firmware is very good, but sometimes they just go a little haywire on you. So it's always best to reboot the phone using ******. It's kind of a little hidden trick, I suppose. But be careful. On the newer versions of Call Manager 4, well, some early versions of Call Manager 4, you could do it from anywhere. But new ones, when you hit ******, it thinks you're dialing. So it puts it up there as a phone number. What you want to do is you want to go in and go to a menu of some sort. Pull up the setting menus or something, and then hit ******, and that will reboot the phone. You can see it just flipped over to resetting right there. Reboot the phone, kind of clear out whatever configuration issues it's having, and that will give you a fresh, clean slate to start up with. So that's always the first step, is just make sure it's not a simple reboot. It's like when you're talking to people with Windows computers, and they're like, it's doing this and that. You don't even let them finish. You just, did you reboot yet? No. Oh, reboot fixed everything. So do the same thing with the phone. Watch for the status messages. And I showed you this already. From the settings menu, you can go to status. You see them real time on the phone, but a lot of them fly by so fast you can't see. So you'll be able to go back and see status messages, what it's been looking for all this time, and it'll also pop up a lot of the common errors. Now you can go to the Cisco website. If you ever see something like CTL update failed, just go to Cisco website, type that in quotes, and it's going to pull up direct results saying, well, here's what that means, and it'll explain all of those messages to you. You can also Google for Cisco IP phone status messages. The reason I put that there is because there is actually, let me see if I can find it. Just scrunch this down right here. Go to Google and type in Cisco IP phone status messages. Put it in quotes. And what it should bring up, status messages. Here we go. Oh, beauty. There it is. You see it. First hit right there. It comes up and shows you all of the different status messages that you can get on the phone. Config file not found. Here's the reasons for that. Check your TFTP server. Config TFTP size error. Power cycle of the phone. So all of these things, every message that you can get on the phone is given to you right here in this beautiful table, which you can reference and say, okay, well, based on that no CTL installed or whatever message, this is what it means. Verify your IP configuration. Now this is the one I can't show you on my soft phone because it doesn't have the network menu. So what I did, I just grabbed, between the recordings, I grabbed my cell phone. Whoa, that's huge. And took a picture of the phone, and I was like, hey, that's not bad. So this is my 7970 phone that I just took a snapshot of. I just went to the settings menu. You can see from here, this is a place where you can go verify the IP address, verify the subnet mask, and so on. Now, one of the things I want to make sure I mention is none of these values are changeable by default from the phone, because you can see this little padlock right here. All the settings are locked, and that's good because you don't want your users coming in and goofing something up. Oh, let's they're bored at work. What does this do? So this little padlock keeps them from changing anything from here. Now, just like rebooting the phone is *****, you can unlock the phone, meaning allow yourself to change those messages just by hitting ****#. Just that. Don't hit ****, or the phone reboots. ***# will actually take that little lock and show it go to unlocked, and now you'll get an edit menu, and you can go in and change your subnet mask or IP address as long as it's manually configured, not DHCP. But that allows you to change all of the settings on the phone. You can also, I took a couple more pictures that open monstrously. This is, scrolling down a little bit. I scroll down to option number 20. Sorry, it's a cell phone. I'm sorry. It's option number 20. Operational VLAN ID is showing 600. So it's receiving VLAN 600, and that's a good place to verify, am I getting the right VLAN? Am I on the right VLAN? On the 7970, it also has a place to go where you can verify your call manager configuration. It shows which one is currently active, which one is configured for, in my case, SRST. I don't have a redundant call manager. I do have a router that can fail over as an SRST gateway, survivable remote site telephony, and that allows it to support the phone should that call manager go down. It shows this one is currently active, this one is currently not being used. It's just there as a backup. So a lot of good things that you can verify from the network configuration screen. And sometimes the phone comes from an old network. A lot of times if you buy used phones or you move it from one part of the network to another, the old settings can get stuck in there. And it's supposed to clear out when you reboot the phone and get a new DHCP address and all that, but I'm telling you, this is just from sheer experience. Cisco documentation says it clears itself out, but sometimes it just doesn't. They just get stuck in there. Go to the network menu, and this is different on every phone. On the 7970, matter of fact, here, I'll take another picture on my cell phone. All right, I just took some more pictures and imported them right here. When I go to my 7970 phone and hit ** under the network configuration, you can see it says right here, settings unlocked, and immediately this erase button appears. And that is on 7970s how you can erase all the network configuration settings is just by hitting the erase button. On 7960s, and well, it's different for everyone, but 7960s and 40s, you actually have to scroll down to a menu option. I think it's like number 33. I've been there a few times. You scroll down to a menu option and select erase configuration rather than just having a handy erase button right there on the right hand side. I also wanted to show you, I went ahead and hit ** one more time to relock the settings, and notice the erase button disappears from that 7970. So it comes when it's unlocked and disappears when it is locked to keep users from doing it. But that is a great way from the phone to troubleshoot your config. In addition to doing troubleshooting at the phone, we can do it on our call manager as well and do some very significant troubleshooting. First and foremost, we can ping the IP phone. Make sure that the call manager has connectivity to the IP phone, and that's one of the basic tests. Call Manager 4, you open a command prompt. It's Windows, and you ping it from the command prompt. Call Manager 6, you can do it from the command line, but it's not as logical as you would think. Like, let me bring over the command line here. I can't just type in, I have my phone right next to me. It's 172.30.60.29. It says, no, it's not a valid command. You can't ping that way. You actually have to do the, what was it? It's utils, network. Network ping, and then we can do our 172.30.60.29. Because remember, this is not the Linux operating system. This is a custom little command line interface Cisco has written for some troubleshooting. But that's how you can ping from the command line of the call manager. But why do it there when you can do it from here? The Cisco Call Manager includes a operating system administration GUI. You get there by going to this little drop-down navigation. It's not administration, not serviceability, it's OS administration. And that'll take you here. And underneath here, you have some pretty significant things you can do. This is where you do, for instance, your upgrades to the operating system and so on. But right under the services menu, got a little ping. You can come up and say, give me a 172.30.60.29 and give it to me 5 times. Hit ping. Goes out, does its ping, and you can see right there it's feeding into that ping results window, letting me know that the ping is successful. Same thing. So without having to SSH over to my server and do it from that command line, I've got it in the GUI. From here, you can also do things like check out your TFTP files. In Call Manager 4, you can, as I mentioned this before, you can just go to a directory in the program files, Cisco directory, to start looking at the TFTP files. But on here, you have to manage it all through the web interface. And you can see this is where all the files that support the phones are. You've got the 60 dictionaries. It's the English dictionary for it. You've got the enunciator, and that's where you've got the we're sorry, this such and such, all the enunciator recordings for the phone if you missed out. So that's, I mean, you can see you have 316 files. There's tons of files on there that support the phones. Music on hold, ringtones, all of that is sitting on the TFTP server. You can verify and restart your services, and we've seen that already. Let me just take you to back to the serviceability. Hit the redirect loop. It's requesting this address in a way that will never complete. That's a new one. Please hold. Talk amongst yourself right now. Just going through, getting reconnected. Serviceability, go. Well, I have to say that was weird. A redirect loop that will never complete. There we go. I'm in the serviceability. Tools shoot down to feature services. And this is, I showed you this before, but you can also go in and restart the call manager services. If something is just strange, you say, changes aren't taking effect, something is weird. Sometimes just restarting the service helps out. You can see that up here we have stop, we've got start, or restart right here. So I'll click on restart, and you can see that it is going to restart the service, and when it does, my phone will probably die. Yep, there it goes. And you can see the phone dies. My SRST gateway is currently powered off because it's too loud. It's 2800 and it's loud in my office. So it's currently restarting. It does cause the phones to jump ship, go to another call manager. That will a lot of times solve issues if change. And usually I've had to restart the call manager service when, again, it's the strange things like changes aren't taking effect. I change a phone number, it's not updating. I just say, okay, let's restart the call manager service and see if that fixes it. Very, very few times will you have to do that. Nowadays, in the modern versions, it's typically in the old versions where there's still a lot of bugs. And then finally, create a new configuration file. I talked about that one before, so I won't reiterate it all again. That's where you delete the phone in the call manager and recreate it, which recreates a configuration file for the TFTP server. Last but not least, let's look at troubleshooting SIP devices. SIP devices, or SIP in general, is opening the doors for all kinds of crazy stuff to happen in the voice over IP world. SIP, the Session Initiation Protocol, is that open standard voice over IP protocol that is going to be the future of everything voice. The writing is on the wall. Eventually, H323, MGCP, well, these are all debatable comments I'm making, but all these other protocols will go away and there will just be SIP. It'll be like the TCP/IP of voice. Now, Cisco is beginning a slow migration away from Skinny to allow their IP phones to use SIP. The problem is that the older phones, such as the 7905, 7912, 4060, etc., there are older phones out there, they don't support the keypad markup language. And that means that the firmware that they have, and just it's a hardware limitation, the firmware that they have won't be able to support KPML, which allows you to assign a lot of the buttons different functionality on the phone. So that means those phones can work with SIP. They have SIP firmware. You can take them to any vendor call management system that uses SIP, and they'll get dial tone and be able to place calls. But they have limited functionality. A lot of the buttons won't work right and things like that. There'll just be no function when you push a button because it doesn't support KPML. The newer phones, or what's called Type B phones by Cisco, which is everything but those models that you see here and the other older phones, support KPML, and thus they can get near full functionality, and I would say nowadays just about all full functionality using SIP, because Cisco now has the ability to allow any key to do anything in the IP phone. And I don't know if you noticed when I opened the call manager device default screen when we were talking about the firmware, I don't know if you saw, but a lot of the phones coming out now are SIP-only phones. You can see 3911, 3951, and I know these are kind of niche phones for kind of like retail stores and so on. But a lot of the phones are coming out with SIP flavors of firmware that they are supporting, and they can do just fine. You see all the SIP going all over the place. So SIP is slowly emerging as like this is the way to go, but still there's plenty of devices that are skinny only. So eventually, you'll see nothing but SIP in that list years from now. But that's one of the big limitations, is make sure that when you're troubleshooting these devices, you're not trying to get functionality on a phone like a 7960 that's just not supported with a SIP firmware. Make sure that you're using the SIP firmware for the phone. A lot of times, the phones ship with skinny firmware on them. You'll have to change them and upgrade them to SIP firmware if you want to do that. And then if you're using digest authentication, you can actually authenticate the phone. Make sure that both ends are configured and both ends are configured correctly with the correct digest to authenticate accurately to the server. So probably one of the biggest areas of troubleshooting that'll hit you right up front, but thankfully it's usually one of the easiest to troubleshoot, is the endpoint registration. Phones just aren't booting, they're not registering correctly. As I mentioned, 90% of the time it just comes from understanding that IP phone boot process, to knowing those steps the phone goes through from the moment you plug it in and it gets electricity through the end to where it registers with the call manager. Knowing those pieces will guide you in your troubleshooting of the boot process. We looked at troubleshooting from the phone, looking at the settings themselves, network configuration, erasing the network settings, rebooting the phone using that **# troubleshooting from the call manager, pinging the device, restarting the services, checking the files on the TFTP server. And then finally, we looked at troubleshooting the SIP devices, which could be Cisco phones. They could be any vendor phones, because SIP is that open standard that everybody is starting to support. So third-party phones could come in there as well, and that's of course when you call Cisco, they'll say refer to the third-party documentation on that device. So I hope this has been informative for you, and I'd like to thank you for viewing.